everyone, in today's lesson we're going to talk about a concept called use substitution. So the directions here say evaluate each integral using use substitution. So why do I have to use this method? And what is it? So obviously you guys know that you could solve this integral by hand. You would just have to triple distribute this 4x to the third plus 3. So don't write this down, but this is what you would have to do. 4x to the third plus 3 times 4x to the third plus 3, and then times another 4x to the third plus 3, then times the 12x squared, that's next to the dx. You triple distribute that, then you distribute the 12 in, and you get some polynomial. Then you can absolutely add 1 to the power, divide by the power. But I think that would take a very long time. So there now involves a new process called use substitution. So the way use substitution works is step 1 is always going to be to let u equal the stuff inside the parentheses. So let's do that. So let u equal 4x to the third plus 3. Step 2, take the derivative. So du. So du means I'm taking the derivative. So 4 times x to the third is 4 times 3 is 12. Drop the power down by 1. And the derivative of 3 is just 0, right? The derivative of a number is just a constant. And then we always have to write dx next to it because it took the derivative with respect to x. So if we want to write down some steps, we did what? We found du. And then step 3, the last thing we need to do is we need to solve for dx now. So obviously this 12x squared is attached to the dx by multiplication. So we can divide it. And that is what dx is. So du over 12x squared. Now step 4 is plug it into the integral and solve, or integrate rather. So maybe I'll change that. I won't say solve. I'll say plug in and integrate. So let's do that. So we've got the integral. I'm going to use a different color now. We've got the integral of this to the third, but this is u, right? We let u equal 4x to the third. So it's u to the third, and then 12x squared. We're going to leave. And now we're solving for this dx. So the dx is this. So now we've got u to the third times 12x squared times the dx, which is du over 12x squared. Now, this may look very funny to you. You absolutely cannot integrate this with x's and u's. But what happens, you should notice that this 12x squared cancels with this 12x squared. So we now have the integral of u to the third du. And that is absolutely okay because we have the same variable. So what is the integral of a simple thing like u to the third? Well, we add 1 to the power, so u to the fourth over 4, and then put a plus c. So then this leads me to my last and final step. Step 5, plug x back in. So if u was equal to this stuff, 4x to the third plus 3, we're now going to put the x back in for that spot there for u. So 4x to the third plus 3 over to the fourth over 4, then plus c. And this is a simplified version of our integral. All right, so I know that's a lot of steps, so we're going to do that all over again through another example. Example number 2. So again, step 1, let u equal the stuff that's inside the parentheses. So in this case, my parentheses are down here. That's totally okay. So we're going to let u equal 4x to the fifth plus 5. We're going to take the derivative, which is step 2, du. So the derivative of 4x to the fifth, you multiply the 4 and the 5, you get 20. Drop the power down by 1, and the derivative of 5 is nothing. And then we just have to put dx because we took the derivative of x. So step 1, done. Step 2, take the derivative, done. Step 3, solve for dx. I can divide by 20x to the 4th. So my dx is now equal to du over 20x to the 4th. All right, step 4. Let's substitute what we have. So 60x to the 4th over, this is now u, so u to the 3rd, and dx is now du over 20x to the 4th. Now, can't take the integral with x's and u's. So let's see what we can do here to simplify this. Well, the x to the 4ths will cancel, that's for sure. And I can divide 60 and 20. That'll give me 3. So I really have the integral of 3 over u to the 3rd du. And we still can't integrate this because of this u to the 3rd that's on the bottom. We can throw that upstairs and just make the exponent negative. So this is 3 u to the negative 3 du. And now that is definitely something that we can integrate. So now we're up to step 5. Let's integrate. So if we do that, we're going to add 1 to the power. So remember, when we add 1, we go down, so negative 2. So add 1 to the power, divide by that power, and then put a plus c. And then the last and final step is going to be to substitute what we let u be and put it back in. So if u is 4x to the 5th plus 5, I'm going to put 4x to the 5th plus 5 in for that u. So it's 3, 4x to the 5th plus 5 to the negative 2 power divided by negative 2 and then plus c. And that is my answer using u substitution. All right, why don't you guys take a look at example number 3. And I want you to do this one for homework, and this is where we will start class tomorrow. I will give you a hint. You may need to change the cube root of 3x squared minus 2 to 3x squared minus 2 to some power that's a fraction. And then do the same process with u substitution. If you can't get it, just try your best, and then we'll go over it in class tomorrow. All right, that's it. Have a great night.